On your own 5.1, we're talking about polyatomic ions. To refresh your memory that a polyatomic ion is an ion which form when a group of atoms gain or loses electrons. So we're talking about a molecule, right? A group of atoms. The polyatomic ions that you have are all covalent ions, or covalent molecules. You might think of them as molecules because they're groups of atoms. They're bonded together covalently, and yet they have a net charge, meaning they, as a group, are going to react with another ion ionically. Okay? So though they are covalently bonded to each other, they react ionically with other ions. So on your own 5.1 asks the question to name the following compounds. Okay? So remember, we're talking about an ionic compound, right? An ionic compound that has within it a covalent structure. The covalent structure here, where there's more than one, it's included in parentheses. Where there's not more than one, the parentheses are not there. You could look at this as Na and then parentheses around ClO3. Okay. At the bottom, Li parentheses Cn. Parentheses aren't required because there's only one of that polyatomic ion involved here. So it's an ionic name, which means we're not have to worry about dis, tris, all that kind of stuff. We're using the ionic naming paradigm. So the first one, what's the name of that first one? For those of you that didn't do 2 and 3, help me out here by at least giving me some of the answers on number 1.
Barium nitrate.
Barium nitrate, right? Ends with an O, so it's going to end in either an ate or an ite. Starts with nitrogen, nitra, so you see nitre, the NITR comes from the nitrogen part of the molecule. Oxygen means it ends with an ate or an ite. The fact that it is an ate, what does the ate indicate?
More oxygen.
More than its pair. So there must be since there's a chlorate, if there's a chlorite, that chlorite will have less oxygens than the chlorate. And chlorite is NO2. Chlorate is, excuse me, I'm on the nitrate. Nitrate and nitrite, so nitrite would be NO2, nitrate is NO3. So how many nitrate ions are involved in this molecule? 2, okay? Two of everything that's indicated here within the brackets. Okay. And the reason why we show that bracketing might be because we want to reinforce that this is its own structure that's connected to another, that's attracted to this other ion. And part of it is so if we have a subscript, in this case there's more than one of them, we know which of the atoms get multiplied by that second subscript to figure out how many of each element, how many of each ion are involved in this molecule. So we say, well, this molecule of barium nitrate has 1 barium, 2 nitrogens, and 6 oxygens. Those 2 nitrogens and 6 oxygens are all combined together to form 2 structures, each one of which has 1 nitrogen and 3 oxygens. And that 1 nitrogen, 3 oxygen combination has a charge. That charge is what? -1. Since that nitrate has a -1 charge, or 1 negative charge, it takes 2 of them to cancel the charge of a barium ion, which is a column 2A element, means it's a +2. That's why it takes 2 nitrates to equal and counter the charge of 1 barium ion. Okay? Next one. Yes, sir?
Sodium chloride.
Sodium chlorate, right. Sodium chlorate. And see that the ClO3, that's a Cl, the L is lowercase, right? So it's part of the uppercase in front of it. It's not Cl, it's ClO3. If that's a chlorate, what must a chlorite be? ClO2, right. Now, how do we know that it's 1 sodium and 1 chlorate? Right, and then we know they come together because what's the charge of a chlorate ion? -1, and a sodium is a +1, so it's a 1-to-1 relationship between the two. They balance each other out, same magnitudes, opposite charges, so the charges balance. And now this molecule has a net neutral charge. The chlorate doesn't have a net neutral, and the sodium ion does not have a net neutral, but the molecule of sodium chlorate is a net neutral. And we reach that net neutral by opposite charges being attracted to each other until they all cancel out. Okay. The next one. Yes, sir.
I get 2 questions actually.
Yes.
Now, if they equal out, so if there's one ion and one of the other ions, we don't have to put the parentheses. But does it matter if we put them or not?
I'm not going to take off if you put parentheses around it. Technically, again, for me that shows, in this case, if you put parentheses around ClO3, and the 3 is inside the parentheses, right? Because that's the entire polyatomic ion. To me, you're showing me that you understand that that's a structure on its own. Is it required? No. Is it required if there's more than one of them? Yes, absolutely it is. So there's 2 things I could assume the best in both cases. I could assume if you put parentheses around it and it's not needed, is that you're indicating to me that you understand that that's a structure within itself. The second one would be, if you don't include them, that means you're savvy enough to recognize it without needing that structure, right? You see that it's a ClO3 molecule, or excuse me, ion, without putting brackets around it. So both of those, I'll give you the win-win on that one for now. Okay?
And calcium hydroxide?
Mm-hmm. Calcium hydroxide. The hydroxide ion, we've already spoken about that, has a net -1 charge. Okay? Calcium is a column 2A element, so it has a +2 charge. It takes 2 at 1 negative to balance out 1 at 2 positive. So calcium hydroxide. And lastly, lithium cyanide. Okay? Cyanide. Well, lithium has what charge? It's a +1 charge, column 1A element, so cyanide must have a -1 charge. You would have to know that cyanide, that's the symbol for it, that has a 1 negative charge, so that you could balance it out to come up with LiCN. Okay. Poison, kill you. So, on your own, 5-2. Now, one of these, I think it's actually the next one. So, 5-2, give the chemical formula for, and it lists several molecules, right? So the first one is potassium sulfate. Again, I worked this into the paradigm we used for ionic compounds. So the first question we asked when we were dealing with ionic compounds was, what are the 2 elements involved in the molecule? In this case, though I say, what are the 2 elements involved in the molecule, we know that we're looking at one of them is going to be an element that becomes an ion, and the other one is going to be a polyatomic ion, which stays itself. Okay? So what are the 2 primary, the element and the polyatomic ion in play for potassium sulfate? Ma'am?
Potassium sulfate.
Potassium and sulfate. Right? Sulfate. We're going to look at the whole molecule. So potassium and sulfate. So we know it's potassium and sulfate, but we know it's not potassium atom, it's a potassium ion. So you ask yourself the question, what charge does potassium take when it becomes an ion? And what would that charge be? Just tell me.
Is it a positive one?
Yes. Let's say it like we know it. It's +1. Good. It's +1. It's a column 1A element, so it ionizes to be a +1 charge. That potassium wants to get rid of that 1 valence electron. When it does that, it takes on a +1 charge. Sulfate has a 2 negative charge. So by the process we've learned now, what must the formula be? Yes, ma'am?
It would be potassium and the 2 and then sulfate.
Okay, so we have 2 potassiums and 1 sulfate, right? To look like this. Okay. There's nothing different or scary about this than what we've learned for the last 3 weeks. It's just because we now have this bracketed, and it's bracketed so you can think of it all as one thing, right? This whole glob, this whole SO4 structure has a 2 negative charge. And so we'll treat it like it's an atom. How many of them would have to balance out the positive charge, or how many of the positives would need to balance out? Well, we drop the charges, remember, and transpose as subscripts. And when we write it as the formula, we're going to change the brackets into parentheses to show that structure. So here it's K2SO4. We could go ahead and rewrite that without the parentheses. Okay? And I'll argue that this is a more appropriate way to write it. However, for us right now, if you wrote it this way, I would accept it. I'd be happy with it. Okay? If you need to see the bracket to keep the idea of the polyatomic ion in your head for now, we'll go ahead and do that. Won't count it as wrong. It's just not as correct as it could be. Think of it that way. So the molecule is K2SO4. Why? I need 2 at 1 positive to balance out 1 at 2 negative. So the molecule that's formed, this potassium sulfate, is a K2SO4 molecule. Questions on A? Okay. So for ammonium carbonate, this one's a little different. Why is it? What is the element involved here? Or is there one? There's no element involved here, right? We have 2 polyatomic ions. An ammonium polyatomic ion and a carbonate polyatomic ion. So if memorize table 5.1, ammonium is an NH3 structure that has a +1 charge. And I may sometimes slip, I almost did there, an NH3 molecule. It's not technically a molecule, it's a polyatomic ion. Okay? So there's no such thing as the ammonium molecule, technically. But if I say that, you'll get that what I'm talking about, right? It's the ion. Yes, sir?
I got NH4 in my book.
Yes, that's correct. This is a typo. This is ammonia, not ammonium. So NH4, but it's a +1 charge. So other than the subscript 3, in your notes, change that to a subscript 4. So this is ammonium carbonate. That what is up there is ammonia, which actually is a molecule, not a polyatomic ion. So NH4 has a +1 charge, and carbonate, CO3 carbonate, has a 2 negative charge. So that typo probably carries over. It does. Okay. So it should be NH4 subscript 2 CO3. Does everybody see how we came up with that 2 ammonium and 1 carbonate? Okay. Now, if we were to shorthand this one, I don't think I do, would it be appropriate to write parentheses NH4 and parentheses 2 CO3? It would be, because there's only 1 carbonate. I don't need the parentheses around the carbonate because there's only 1. But if you wrote it like this, again, I would be thrilled right now to get it right. Do better than this, because don't include the typo of the 3, put a 4 in there, okay? So do even better. What does that mean? Right there it is. Again, other than that little black spot which is on the board, not on the slide. I have 2 ammoniums, here shown as ammonia, but it should be 2 ammoniums, each of which has a +1 charge, and that should equal an opposite charge of 1 carbonate, which has a 2 negative charge. Since they are equal but opposite, it's true, and that molecule is written correctly. Okay. C. Give the chemical formula for aluminum acetate. We have 1 element, which is actually, we're talking about the ion, and 1 polyatomic ion in play, right? So obviously it's aluminum and acetate. You need to know that acetate, not only its formula, but its charge, 1 negative. So the question then is, what is aluminum? What does aluminum ionize to become? Looking for a bold volunteer. Aluminum becomes 3 positive, right? It's column 3A element. It's a metal. It loses. So by process, then, what is the formula for aluminum acetate? Go ahead, give it to me. What is it? Don't know?
Al, parentheses, C2H3O2, in parentheses 3.
Mm-hmm. Don't take a high five if you weren't bold enough to give the answer. That's pretty lame.
Oh.
I knew it in secret, but I wasn't willing to speak out because I might have been wrong, and then you'd think less of me. No, not in this class. Not in this class. Kind of need to keep moving. And having a conviction on an answer, even if it's wrong, is better than having the right answer in secret. Okay? So, it takes 3 of the acetate polyatomic ions to equal the opposite charge of 1 aluminum ion. That's why we write it in this manner. Okay? And the 1 positive 3 balances out the 3 negative 1s. All right. Again, if I remember correctly, 5.3 gives, it's more of a statement question, right? It gives several different names, and you're supposed to write down the formulas for all the names of different molecules. And all I did was basically go through and did like we did on the last problem, and wrote down all 4 molecules. So what I've done is kind of change this into, give the chemical formula for aluminum nitrite. That's one of the first molecules that should have been there on that question. Aluminum nitrite. Nitrite, excuse me. So, same question. What elements or polyatomic ions are involved in the making of this molecule? Somebody from the first row. What is the element and or polyatomic ions, this row there, that side over there, involved in the making of aluminum nitrite? Go ahead.
Al.
Oh, you both, she put her hand up just as I said go ahead.
Me.
Go ahead, ma'am.
Oh my gosh.
Okay. Aluminum was the element, and she already said that it becomes a 3 positive ion. And nitrite, NO2, as opposed to nitrate, which is NO3. Now, just because it's a 2 or a 3 doesn't tell you what the charge is going to be. You're still going to have to memorize that, okay? Okay, but that little trick of 8s and ites helps us know, okay, ite is 2, then 8 must be a little bit more on the oxygen. So, this molecule, aluminum nitrite, is formed with the Al3 positive, the aluminum ion, which is a 3 positive, and the nitrite polyatomic ion, which is 1 negative. So what, second column, what combination do I need here to have a neutral charge? What's the formula for this molecule? Go ahead, ma'am.
Is it Al, and then parentheses, NO2, parentheses 3?
It is. Al, parentheses, NO2, parentheses 3. I may say that Al, pause, Al, NO2, sub 3. Okay. How many aluminum ions are involved in this molecule? For one molecule, how many aluminum ions do I need? 1, okay. How many nitrogen do I need? 3. And how many oxygen? 6, correct. So in the form AlNO2 sub 3, I need 1 aluminum, which is a 3 plus charge, and that has to equal with an opposite charge of 3 nitrates, each have 1 negative charge, and so 1 times 3 equals 3 times 1. That's correct. The next molecule in the question is the chemical formula for sodium carbonate. So this row right here, what are the elements and or polyatomic ions involved in the making of sodium carbonate? Go ahead.
Is it Na1 positive and then CO sub 3, CH2 negative?
Okay. So sodium is the element involved, and she's already said that it becomes a +1 or one positive ion. It ionizes to a +1 charge. And carbonate, which is a CO3 polyatomic ion, which has a 2 negative charge. So the formula for sodium carbonate is this row again. Somebody over here. The formula would be Na2CO3. Right. We'll check it with 2 sodium ions with +1 charge. 2 times 1 positive has to equal but opposite 1 carbonate, which has a 2 negative charge, and it's true. So the formula is correct because the charges balance, and if you want to get technical about it, they have no common factors other than 1. So they're already reduced by the greatest common factor. If it was Na4CO3 parentheses, right? But here, we only have 1 CO3 molecule, or excuse me, polyatomic ion. We only have 1 of them, so we can't reduce it anymore. Okay? That's one place to not get tricked, to think that, okay, if there's a C2O6 or something like that, that you could reduce them all by 2. That's part of keeping the brackets, might help you remember, this is a unit. I can't mess with the unit. Okay. C, aluminum carbonate. Now, we're going to be repeating ourselves, aren't we? We've already done aluminum and we've already done carbonate, but we haven't done aluminum carbonate. If you go back, it was sodium carbonate. Now it's aluminum carbonate. So we've already said that aluminum becomes a 3 positive and carbonate is a 2 negative. What is the formula for this one? Middle row. Somebody else. Middle row here. What is the formula for aluminum carbonate based upon these ions? Correct. Al2 CO3 sub 3. I have 2 aluminums, 3 carbons, and 9 oxygens in this molecule. Okay. The 2 at 3 positive equals and balances out the 3 at 2 negative. So 6 equals 6, it's true. All right? And lastly, what about the other element and polyatomic ion? That's right, sodium nitrite. So you see what happens? We took 2 molecules, broke them apart, switched their partners for this reaction. And we'll see it in the next slide. But right now, what's the chemical formula for sodium nitrite? We've already done sodium, we've already done nitrite. Sodium becomes a +1 ion. Nitrite is a -1 ion. So the formula is NaNO2. One of each. The 1 at +1 equals an opposite of 1 at -1. 1 equals 1. Now, what does this look like, this whole formula for this question? It says aluminum nitrite and sodium carbonate produces, see how they just swapped them out? Moved them around? You see all the building blocks are there, but here's a question. Is this balanced? We're not quite to balanced reactions yet, but this is kind of pushing into not molecular geometries, but even modules in the future, we look at this. Remember, we cannot create or destroy anything, right? All we can do is rearrange it. Question, look at how many, well, for example, carbonates. How many carbonates do I have? Just 1, right? But it makes a reaction that produces carbonates down there. How many carbonates are in the products? 3. It looks like we gained 2, doesn't it? But we can't. We can't gain 2. We can only have as many as we had before. Oh, but let's stop for a second too and say, okay, let's not look at the carbonates. Let's look at carbon. How many carbons do I have in the reactants? Count up the carbons in the reactants. How many do you see? Okay, the reactants are these, right? Count up the carbons. Are there any? No. 1. I got 1 carbon. How many carbons do I have in the products? 3. So how am I going to end up with 3. Don't I have to start with 3 to end with 3? So we balance the reaction by doing this. Watch what happens. Aluminum, I have 1. Aluminum, I have 2. How do I get 2? I need to have 2 of them to start with. I have to start with 2 to end with 2. Okay? Nitrite, 3. 1. I must need 3, but for other reasons we'll find out that there's 6. If we go through each element, and with the polyatomic ions go through each polyatomic ion, we then have the ability to say, I can generally say that this and this react to produce this and this, but more specifically because of the numbers up here, I could say for every 2 of this molecule, it reacts with 3 of this molecule and produces 1 of this molecule and 6 of this molecule from the information that we had to begin with.